let's first review a few things that we talked about yesterday. So we talked about how if we can rewrite exponential functions with the same base, then we want to do that. Because if we can rewrite them with the same base, what can we do with the exponents? If the bases are equal, what else has to be equal? Yeah, the exponent. So if we can do that, we want to. We want to do that without a calculator. Okay? But in some cases, we can't do that. So let's look at part D. My bases are 4 and 5. I could rewrite 4 with a base of what? What could I rewrite 4 with a base of? 2. Okay? Could I rewrite 5 with a base of 2? No. Okay? So really, I can't rewrite 5 with a base of anything. So that's where the second step is going to come in. So yesterday on your guys' notes, you wrote out there were 2 ways to solve. I'm just going to point you back to that real quick. So it says the first way is to rewrite with the same base, but then the second way is to take the log of both sides, and that's what we're going to have to do with a calculator. Okay? And the reason why we can do that is because the relationship between exponential functions and log functions are that they're what? That they're inverses. Okay, see I wrote that up on the board for you too. Exponential logs are inverses, which means they do what? What do inverses do to each other? Yeah, they cancel out, they undo that operation. Alright, so for part D, since we cannot rewrite with the same base, there are 2 different ways to do this, and I'm gonna show you. So if you can't rewrite with the same base, okay, you are going to use logs. And again, you're using the logs because that is the inverse. Anytime you are using your log and you have a long decimal, you are going to round any decimals to 4 places. So that's just the standard place that they round logs to. Okay, because you have a lot of digits there. And then, like I said, there's 2 ways that you can do this, and I'm going to let you choose which way that you like the best. I'm just going to show you both ways. So the first way is using the common log. Remember, the common log is a log with what? Yeah, it's a log with base 10. Now, you need to write this out. I know some of you are not going to like that very much, but you need to write out your steps. There's a very certain way that you have to show your cancellation. So if you use the common log, you're going to have to write out the log on both sides. And the log goes in front, like this. Okay, so the log goes in front of this side, and the log goes in front of the other side. Now, based on what we learned yesterday, we learned about this power rule, where if you had an exponent, where could the exponent go? Using the power rule. Where does it go? Yeah, multiplies where? In the front. So this would be x minus 1 times the log of 4 equals the log of 5. Absolutely. Now remember, the whole goal is to get x by itself. So we want to move over anything that is not the x. So the first thing we're going to do is divide both sides by the log of 4. And the reason why is because when you divide, those will cancel out. You'll have x minus 1 equals the log of 5 divided by the log of 4, which we will calculate in a moment. And then your last step is just going to be to do what? Add 1 over. Okay, and then we are just going to calculate this. So we learned how to calculate this yesterday. Okay, and you can do this in 2 steps or 1. So the log of 4, or log of 5 divided by the log of 4. Because remember, your calculator log is the common log. And then add 1. And then we're going to round this to 4 decimal places. So if you're rounding to 4 decimal places, what decimal place do you have to look at? The 5th one. Okay, because if you want to round to the 4th, you look at this to determine if it's staying or if it's going up. And this one is doing what? Going up. So if it's 9, it means it bumps this whole thing up. There's a 0 in front, so it would just be, bump it up to 10. So it will be 2.1610. And yes, you do need to keep the 0 at the end to show that that is rounded. Okay, so you have to keep the 0 at the end to show that it's rounded. Okay, so that's the first one, is the common log. Any of you know what the second one is? So yesterday we learned about different logs. We learned about the change of base formula, which I kept up on the board. And with the change of base formula, we could use the log base 10, or we could use the log with what? Remember we did some of those yesterday by hand? You can use the log with any base that you want to. Okay, so use a log with the same base. Okay, so use the log with the same base as the exponent. What is the base of my exponent in this equation? What's the base? What is it? What's the base? 4, right? So let's just do log base 4 of both sides. Okay, so for this one, we use log base 4. So if we do that, again, you need to write this out. So you would write log base 4 of 4 to the x minus 1, and then log base 4 of 5. Okay, now why is that helpful? What's going to happen over here? Yeah, they cancel. Remember we did a bunch of the canceling yesterday? And then you'd be left with the exponent, which is x minus 1. And then guess what? Log base 4 of 5. Can't I just use the change of base formula on that? Isn't that my change of base formula? So log base 4 of 5 means use the change of base, the log of 5 over the log of 4. And then plus 1. And then guess what? You get the same thing that you did before. So you use the change of base. Okay, that's how you get this from here to here. Change of base. Okay, so you can decide which one you like better, and you can use that one, okay? And this ripple, I don't like either. Is there one that you guys prefer over the other at this point in time? The second one? Common law? All right, so we'll do, for this one, we'll do both again, and then you guys can decide. Okay, so let's do both of these. Okay, so will you guys write out the step for the common log? Okay, so write that out for both sides. Okay, so again, when you're taking the common log of both sides, you just have to write that step down for me. So you have the log of 7 to the negative x equals the log of 21. And then your next step is using the power rule. So you have negative x times the log of 7 equals the log of 21. Now, when you're dividing this time, if you want, just divide by negative log of 7. Negative log of 7. Okay, so the log of 21 and then you do have to use that negative. Okay, and then we're going to round to 4 places after the decimal. So we have negative 1.56457. I always underline this and then look at the next one. So negative 1.5646. Okay, that bumps it up. All right, and then let's try the second way. Yep. No, you can pick which one. Yes. And even on your homework and your review, you can choose. Okay, so you can choose whichever one you like the best. The second way would be to use a log with what? Yep, so this would be log with base what? 7. Yes. So the other way would be to use log base 7 on both sides. So yeah, using the log base 7, I know is nice because you can cancel those out on the one side. And then as long as you know your change of base formula, you're all set. So show me this step, show me the cross out. Negative x equals log base 7 of 21, and then you would divide by negative 1. So this would just be like anything divided by negative 1, the negative goes in front. So you can think of this as the log of 21 over the log of 7, which is your change of base. And again, you'll end up with the same thing. Okay, how do you guys do? Okay, so you can see that that's going to take some practice because that's new. Okay, so make sure that you guys do your practice. I promise it'll make tomorrow a little bit better for you. All right, now we're going to go to the next page, which is where we're going to talk about solving with logs and exponents. Okay, so we know that the inverse of a logarithmic function is an exponential function. That's something that we've talked a lot about over the past couple days. Okay, well, and last week too. Oops, wrong way. Okay, and then so what we have to do is we have to use exponential functions to cancel out the log. So before, we were using logs to cancel out exponential functions. Now, we're doing the reverse of that. So it's just like, you know how when you multiply and divide, you multiply to undo division, but then you can also divide to undo multiplication? That's what we're doing here. Okay, so we can do something that's called exponentiating. So we can exponentiate each side of the equation, which means you could raise each side as a power. This is also how your book shows it, but I'm also going to show you a quicker way to do it, which I think you're going to like better. Okay, so I am going to show you the exponentiating. Like I said, that's how your textbook goes over it. But another thing that you can do is you can use the definition of a log, okay, or use the definition of a log to rewrite as exponential. So you can exponentiate, I will show you that, or you can use the definition of a log to rewrite as exponential. That's just your bay, right? So log base b of x equals y, and if we rewrite that, it would be b to the y equals x. Okay, so remember that's your definition there. So when we say rewrite as exponential, that's what we mean. Okay, your base, your answer, your exponent. Okay, and then in order to have these functions undo the other one, what we're going to do is make sure that the log and the exponent, they must have the what? What must they have? Well, what did we just do with the log and the exponent? What do they have to have? Yeah, the same base. Okay, so they have to have the same base. Okay, now on the front side of our notes, notice that all of the equations that we just did were all exponential functions, right? All of these were exponential. And what's the domain of exponential functions? All real numbers. So there was nothing that we had to be careful about. But look at all of these. These all have what? These are all what functions? Logs. And what do we have to be careful of with logs? What can't you take? You can't take the log of what type of numbers? Negatives or zeros. So you can't take the log of negatives or 0. So for the logs, you have to make sure that you check it to make sure that when you plug it back in, it does not result in a negative log or a log of 0. Okay? And we'll talk about how to do that, like, in your head versus writing it down. Okay? All right, so for the first one, just like when we had exponential functions and the bases were the same, remember how we could set the exponents equal? The same thing happens if you have the same log. See how both of these are log base 3? Yes, we see. Okay, if the logs have the same base, we can set the values equal. Okay, so what would I be setting equal in part A? Yeah. Good. 6x minus 1 equals 5 minus x. Okay, and then will you solve that for x? Okay, so I would add x to both sides to keep this positive. Plus 1, divide by 7. Alright, how'd we do there? We get 6/7. Alright, now we're going to use some brain power for our check with fractions. So when you're checking, all you're doing is plugging this back in for what? Yeah, so some of this stuff you're going to be able to do in your head, and we'll talk about that. Some of you might like writing it out step by step, so I'll help you work through those. Okay, and the main thing you want to make sure of is that you don't get a negative when you multiply. Now, when you multiply a whole number by a fraction, how are we at that? You just multiply the whole number by what part? Yeah, so 6 times 6 is 36. So this is 36 over 7 minus 1. If I'm subtracting 1, how can I write that as a fraction? If I'm trying to subtract it with 36 over 7, how can I write what? 7 over 7. It's just whatever this denominator is with the same number on the top. What's 36 minus 7? Yep, so we're just going to leave this as 29 over 7, and we're just going to make sure that this side, the same thing happens. Now, if you're using mental math, I would just rewrite this as a mixed number, right? Because what's 5 minus 6/7 as a mixed number? Yeah, but as a mixed number. Yeah, 4 and 1/7. So that's something I thought you guys could do easier, like mentally, right? Because from 6/7, you'd have 1/7 to get to number 1, and then from 5 to 1, so it'd be 4 and 1/7. But yes, you could also just do 35 over 7 minus 6. Either one is fine. Do you guys know how to turn a mixed number into a fraction? Yeah, multiply. 7 times 4 plus 1. Okay, and then, yep, those are going to check. All right, now for B, we are going to exponentiate. Okay, yeah, you're required, just your homework will be online and notes will be on there too. Okay. All right, so for this one, I'm going to show you 2 ways. I'm going to show you how to exponentiate, and then I'm also going to show you how to, you already know the second part, but I'm just going to remind you of that. When you exponentiate, all you have to do is pick out the base. Okay, so if you exponentiate, what is the base of your log? What's the base? Yes. So this is what happens. 6 becomes the base, and then this becomes the exponent on both sides, like this. Okay, so we're exponentiating. If you're exponentiating, you just have to rewrite with the same base. Okay? So if you exponentiate, 6 becomes your base on both sides. And then look here. See how the left side is the left exponent now? And then this side is the exponent now? See that? The reason why we would write that is because what happens with 6 in log base 6? Yeah. So they would cancel, and then you would be left with 2x minus 1 equals, what's 6 to the negative 1? Yes. And then you would solve from here. Okay? So that's option 1. Option 2, and we're going to stop there, because I'm going to show you option 2, because I think you'd like it better. So, or you can rewrite the log as an exponential equation. And the reason why I say I think you'd like it better is because you've been doing this for the last week, right? So this is your base, this is your answer, this is your exponent. So could you guys rewrite that as the exponential function using the BAE? What would you start with? What's your base? Yeah, so it'd be 6 to the negative 1 equals base, answer, exponent. So your answer would be 2x minus 1. And then look, don't you have the same equation now? 1 6 equals 2x minus 1. So either way, doesn't matter to me. You just have to show your work. Okay? And then we're going to solve that for x. Yep.
How does 6 to the... Oh, no. I just...
Okay, yeah. So, yep. So just a quick review. You probably aren't the only one who was thinking about that. When you have the negative exponent, remember you do the reciprocal, and then you raise it to that power. Okay, so the reciprocal of 6 would be 1 over 6, and 6 to the first power would be 6. Okay, and now we're going to solve for x. So we're going to add 1. If you add 1, understand that this is like 6 over 6. So 1 6 plus 1, what's that going to be as an improper fraction? 7 over 6. Great. And then your last step is going to be to divide by 2. Now when you do this, set it up like a fraction, right? When you guys learn to divide 7 6 divided by 2, what did you guys say to yourself? Yeah, multiply by the reciprocal. Good. And then were some of you keep, change, flip? Yeah? So whichever one is good with me. And the reciprocal of 2 is 1/2. So this would be 7 over 12. you are going to check 7 over 12, just plug this in. If you have 2 times 7 over 12, can you guys do that part in your head, or should we write it out? 2 times 7 over 12 minus 1 equals negative 1. So 2 times 7 over 12 is what over what? Yeah, and then 14 over 12 reduces to, or it doesn't even matter. We can just do 14 over 12 minus 1, right? 14 over 12 minus 1 would be what? It would be 2 over 12, which would be, what does that reduce to? 1. Yep. And log base 6 of 1/6 equals negative 1. Yep. Okay, so that's just checking to make sure that your answer is correct. Okay? And then, like I said, we'll talk about some situations where it doesn't always check out. Okay, so for C, let's just rewrite as an exponential right away. Can we do that? Okay, so let's use the base, the answer, the exponent. Okay, and then Cooper, I'm going to have you help me with this. So if I use the base, the answer, the exponent, will you tell me what my equation is?
It would be
Yep, so what's my B?
so 5,
Yep,
3,
yeah, equals.
and then 1/2 x plus 21.
Yeah, great. Okay, so now we just have to evaluate. 5 cubed, Maya, what's 5 cubed going to be? Great. Okay, and if I'm solving for x, I'm just going to subtract 21 from both sides. So this would be 104 equals 1/2 x. And then if I want to get x by itself, Kaden, what do I have to do? Great. Okay, so I'm going to multiply by that reciprocal, which is 2, and then you should get x equals 208. Okay, and this one, when I check, it's going to be just like a very short check here. So when you have a whole number, it's a little bit easier, right? You have log base 5 of, and then what's 1/2 times 208? 104. So I'm just going to plug it in like this. Log base 5 of 125, does that equal 3? Yes, because 5 to the third is 125. Okay? So ones like this, you can check that in your head, that's fine. Okay? I don't have to see that part written out. Luke, if you want to join us closer, you're welcome. You're welcome to do that. Okay? And then the next thing that we're going to do is we're going to use those properties of logs that we talked about yesterday. So if you weren't here yesterday, I am going to go over the process. But then it's really important that you go back and watch that video. Okay, so we're gonna use the properties of logs to help us solve. But before we can do that, before we can use, well, not before we can, we actually use the properties of logs to condense them. What you want to do is you want to write them as a single logarithm. So a single logarithm just means that there's only one log in your equation. Okay? So we're going to write it as a single log, so there's only one log written in the equation. For these, we have to check our solutions because we can't take the log of negatives or 0. And you're going to see that some of these actually have multiple answers because, dun-dun-dun, quadratic trinomials are coming back. You guys remember the form of a quadratic trinomial? It's just the form of a quadratic function. What's that? What's the form of a quadratic? A? Good. Yep, that's it, right? That's a quadratic trinomial. How do we solve those guys? Many ways. 3 main ones. Yeah, quadratic formula. What else? Factoring. And then the last one that has to do with the shape. Completing the, oh yeah, that's when you expand, complete the square. But that does have to do with the shape. Okay, so you can factor, use the quadratic formula, complete the square. Okay? All right, so for example 3, this is where the checking is going to be essential. Okay, so this is where I really want to see you checking them. Okay, so yesterday we talked about if you have addition, you can use the product rule to rewrite that. So when you are using the product rule, you are going to multiply what the logs are of. So this is the log of 12, log base 12 of x times x plus 1. Okay, so if it is addition, you can rewrite that as multiplication. And then we want to simplify. So x times x plus 1 is going to be what? Yes, good. So just distribute because there's multiple terms. So this becomes log base 12 of x squared plus x. This is where you can decide. You can either exponentiate, or I recommend that you just rewrite as an exponential function using your bay. Rewrite as exponential because you have your base, your answer, your exponent. Okay, so Gwen, will you tell me what that equation would be, the exponential one?
Well, to the power of 1 equals x to the power of 2 plus x.
Great. 12 to the first power equals x squared plus x. Nice. Now 12 to the power of 1 we know is going to be 12. And see how we have x squared and x? You guys know what that means we have to do? You know? Do you have a guess? What do you guys think? It's okay to be wrong. Well, we are we're gonna rewrite it so that we can factor. So how do we have to rewrite it? Yeah. So if I want it equal to 0, what do I have to do with this guy? Yeah. Then move the 12 over. So I have 0 equals. Some of you right now saying that's what I thought. Just should have said it out loud. Okay. So now that we have that, yeah, let's try to factor. And then if you couldn't factor, you could use the quadratic formula. Guess what? Lots of times they're going to factor, so please factor. So you're just looking for two values. You know if it's x squared, it's x and x. What multiplies to negative 12 but adds to 1? Sorry, there's a lot. Multiplies to negative 12, adds to 1. 6 and 2 when it add to 1. 3 and 4. Okay, which one has to be positive? 4, because the 1 is positive. And then remember how we solve this? We have to set each one equal to 0. Okay, so then you have two possible answers. You have x equals negative 4 or x equals 3. Remember, this is all stuff we did in chapter 2 here, right? And we always wrote these with an or, and that's because we didn't know what x was. There were two possibilities, right? Both of these would work if you plug them back in here, okay? But when you're solving and you have the log, you have to check, because sometimes one of them doesn't work or sometimes both of them don't work. So this is where the check is essential. Because I'm checking two things, I just have to identify which one I'm checking. So I'm going to check the negative 4 first. And this is just how I show it. Okay? So what I'm going to do is I'm going to plug this in. So I have log base 12 of negative 4, and right away that's a problem. Why? It's a negative. Okay? I'm just going to write out the rest of the first step, and then we'll stop. So if you write that out, and then if I'm plugging negative 4 here, can we simplify that part in our head? What's negative 4 plus 1? Negative 3. So can I just put that there instead of doing the 2 steps? Okay? So then, this is where the problem is, and this is why sometimes people get confused. So if you have a negative here, you can stop. This is not a valid answer. So you can't take the log of a negative number. So this solution is invalid. Which means when you're writing your final solution, you are not going to include negative 4. Okay, so this solution is invalid, not valid. Now, I told you that sometimes people get confused because really, if you were to use one of your log rules, a negative times a negative is a positive, okay, but you cannot use that to simplify if they are negatives when you plug them in. So do not simplify that to make it a positive. Once you see you have a negative here, you're done. Okay? You know that it's not going to work. Okay? You also want to check the 3 because depending on the equation that you have, sometimes when you plug in a negative, depending on what it is, it becomes positive. For example, what if this wasn't x plus 1? What if it was x plus 5? Then would that be a problem here? No, because the positive number would cancel it out. Okay? So again, it just depends on the equation. So for this one, you have log base 12 of 3 plus log base 12 of, what's 3 plus 1 going to be? 4. So I'm just going to write that. And then when you are checking this, you can use your log rules. So you can rewrite this as the log of 12 of 12. 3 times 4 is 12. Remember, that's our rule from yesterday, that you just multiply them together. And then, is log base 12 of 12 1? Yes, it is, because 12 to the first power is 12. Okay, and so your solution for this problem is only x equals 3. That's the only valid solution. So if you were doing this on a test or a quiz, okay, this is what you would write on the line. You would have to show this work here, and you'd have to be able to explain why this is not valid. Okay, so this would be a good one to make sure you know how to do. All right, I'm going to have you start B. Okay, so think about what your rule is. So if it's plus, we rewrote it as multiplication. If it is minus, we're going to rewrite it as what? Okay, so if you have minus, you're going to rewrite this as what? Division. Okay, so we're going to use the quotient rule. How did you guys do with that first step? What goes on the top? 100. And then on the bottom, x plus 1. Okay? All right, thumbs up if you got to that point. Okay. All right, and then from here, once you use that to get a single log, now is where you rewrite as an exponential function. Okay, so exponential equation is what you want to do next. Okay, Julianne, will you tell me what that equation will be? So start with your base. What's your base? Yep. And then, so it'll be your base, and then your exponent. Which one's your exponent? Yep. And then you're going to set it equal to, yep, exactly, 100 over x plus 1. Great. Now, if you're going to solve this, you can either solve using cross multiplication, you have to put this under 1, or when you're solving for a variable that's in the denominator, what can you do to both sides? Yeah, multiply by. Yes, but you don't need to do the reciprocal. You can just do the denominator in this case, because the denominators will cancel, and then you'll be left with 100. If you did the reciprocal, you get another fraction on this side. This will eliminate the fraction. And then if you are multiplying 4 times x plus 1, you have to remember to do what? Yeah, you got to distribute to the x and to the 1. Okay, so this becomes 4x plus 4. Okay, so I'm just going to subtract 4 from both sides. So 4x equals 96. Okay, and then we're going to divide both sides by 4. We will get x equals 24. Okay, so sometimes you might only get one answer. We still need to check to make sure it does not produce a negative log. So when you're checking this, you're just plugging it back in for x into the original. So this is log base 4 of 100 minus log base 4. It's 24 plus 1. 24 plus 1 is 25. And then you can use, on this side, you can use those rules. You just want to make sure those are not negatives, okay? So then you end up with log base 4 of 4 equals 1. Is that true? Yeah, is 4 to the first 4? Yep. Yay, so that checks out, and this is your solution. X equals 24.